Amplion is loudspeaker simulation software that calculates sound pressure level versus frequency. It includes a large driver database and offers several useful audio tools. To decide on the type of enclosure suitable for a speaker driver, you must know the Thiele-Small parameters that describe its electrical and mechanical properties. While there are many TS parameters, they are interdependent, and only 6 are required. QMS, QES, FS, MMS, DD or SD, and RE. Other necessary parameters are calculated. Additional parameters are not required for the simulation. The interface offers several convenient features. When entering values, you can use the up-down arrow keys to adjust them by plus or minus 1. Hold Shift or Control while pressing the arrow keys for fine-tuning. Hovering over certain input fields shows a unit conversion. Blue labels can be clicked. The counter displays a full parameter list. You can toggle between some parameters as well as units, rename records, and so forth. Double-clicking in Windows works in various ways. The TXT button in the header shows a list of the main parameters, ready to be copied into a file or onto a website. On the Formulas page, you can see relationships between parameters and copy them into Excel. You can simulate 3 enclosure types. In a closed, sealed box, you define the volume and amount of damping material. Clicking on QTC or double-clicking on the graph is a quick way to change alignment. When the driver is placed in a sealed enclosure, the trapped air resists cone movement, reducing total compliance and increasing the system resonance frequency. F3 is the frequency at which the output of a loudspeaker decreases by 3 dB. F3 is linked to QTC, which describes the loudspeaker's overall damping. A QTC of 0.707 indicates good balance between electrical and mechanical damping. For this value, FC equals F3. Lower QTC means more damping and controlled response, while higher QTC means less damping, resulting in a peak. C8 cm refers to the ratio between acoustical compliance due to air and mechanical compliance due to suspension. By clicking on VB, you can toggle to infinite volume. This option is suited for less damped, high QTS drivers and comes in handy when you want to mount the driver directly to a wall or car trunk with airspace behind it. In a vented, ported box, you define the volume, amount of damping material, and system resonance frequency. Clicking on AC or double-clicking on the graph is a quick starting point. By clicking on DV, you can estimate a suitable vent diameter for low-noise performance. For non-circular shapes, first note the total surface area, then set the dimensions accordingly. Based on your design requirements, adjust the number of vents. Vent end correction affects the total length of the vent. In most standard boxes, the vent is flanged on one or both sides. If the vent is a rectangular slot at the very bottom of the box, then a large part of the air still acts as a loaded mass due to the extended walls. The K is approximately 1.73. A value of 2.23 applies to the very special case of a square vent having the same width as the internal width of the enclosure. LV is the length of the vent. The length of the vent determines its first self-resonance. It is a common phenomenon and can be measured with a microphone in the near field. Standing waves also pass through the vent, so it is not easy to determine the resonance precisely. VA and MA are the parameters of minor importance. A fourth-order bandpass box uses 2 chambers, one closed, one vented. You can electrically connect up to 9 drivers. Moreover, in the case of an even number, you can use an isobaric configuration. In the miscellaneous section, you can define the series resistance, which represents the amplifier's output impedance, as well as the resistance of wires, inductors, and resistors. You can also simulate the effect of added mass to the cone. Lastly, you can simulate the effect of temperature variations in the voice coil, which affect the DC resistance. Cabin gain refers to low-frequency boost caused by an enclosed space such as a vehicle interior or listening room. It is determined by its longest dimension. The walls of an interior act like a closed box, reflecting sound waves. When these waves interact with a direct sound, certain frequencies are reinforced. In a closed box, you can use the Linkwitz transform to reshape the low-frequency response. It allows you to extend bass response or adjust system alignment, enabling deeper bass at the cost of increased power demand and cone excursion. Enabling the voltage SPL section allows you to change the graph to the sound pressure level at a specified voltage at a given distance. That covers the main features of Amplion for loudspeaker simulations. I hope this overview helps you get started with the software and your projects.